Rachel, and today I'm going to be talking about physics and cheerleading, or more importantly, the physics behind cheerleading. When most people hear the word cheerleading, they automatically picture your typical young teenage girl with a large sparkly bow on her head, yelling and shouting for the football boys. However, there's much more to cheer than meets the eye. The main components of cheer are stunting, tumbling, and jumping, and that's where the physics comes in and becomes really important. The main aspect of cheer that I'm going to focus on today is Newton's laws. Newton's first law states that every object in a state of uniform motion tends to remain in that state of motion unless an external force is applied to it. Simply put, this is just the law of inertia, which, as we learned from a young age, means that an object in motion stays in motion unless acted upon by an outside force, or vice versa, an object at rest stays at rest unless acted upon by an outside force. In cheer, this comes into play when putting a stunt in the air. A basket toss is a move where the bases and backspot throw the flyer in the air, and she comes down and is caught in the base's arms. As the flyer is tossed out of the base's arms, she is thrown into motion. However, eventually gravity, which acts as the outside force, causes the flyer to return down safely to the ground. The flyer is the object in motion, and she continues to remain in motion until, once again, gravity acts upon her as the outside force. Newton's second law of motion states that the relationship between an object's mass, its acceleration, and the applied force is F, which is the force, equals mass times acceleration, or F equals ma. In cheerleading, this is important to tumbling. A tumbling pass is when someone runs into a series of connected flips. Whether it be a round-up back handspring or a round-up back handspring back tuck, it always involves running into it to gain acceleration. As the cheerleader begins to run for a tumbling pass, their acceleration increases, therefore increasing the overall force of the skill. So this means that the faster or harder a person runs into their tumbling pass, the better or more powerful their overall tumbling pass will be. The third and final law of motion from Newton says that for every action there is an equal and opposite reaction. As is the case with all these rules, this law could be applied to almost every aspect of cheer or life in general for that matter. However, I'm going to focus on how it applies to jumps, which is the last of the three aspects of cheer that I said I would focus in on. When I bend my knees to do a jump, they push off the ground, acting as the applied force to cause the upward acceleration that gets me in the air. Yet, we know there has to be an opposite reaction of this force as stated by Newton's law. This opposite force comes from gravity. Gravity causes me to accelerate downwards back to the earth, which would make it the opposite reaction to balance out the applied force. In conclusion, this is how physics has affected my life and continues to affect my life on a day-to-day basis, whether it be at cheerleading practice or tumbling practice. Whether I'm stunting, jumping, or tumbling, understanding Newton's three laws of motion has helped me to become a better cheerleader.